I'm going to walk you through a data science project that you can do on at home that is in the causal inference space. It demonstrates the use of difference in difference model, and this type of problem is highly transferable to many of the problems that tech companies face. So the example is back in 2017, Equifax had a widely reported data breach that caused the stock to drop. So something like this happens all the time in tech companies where there is some bad event and they want to know what the impact is. And here you can look at the impact for Equifax using stock market returns. But when we do this for your company, instead of stock market returns, it may be, say, conversion rates or time spent on site or anything like that. And so I go through and I get stock market data, which you can get through uh, Yahoo Fin stock info. Just Google it, you'll see it. And so I get together the prices of Equifax and various competitors of theirs, such as TransUnion, and also throw in some indexes as well, SPY and VTI. And I get the prices, I convert them into returns, and I plot the returns. And you can see that there are sharp drops for Equifax right at the event. So in here, you see that on the day of the event, which happened on September 7th, but the first day of trading afterwards was on September 8th, and the stock dropped by 13%. Right now, for this is a simplified exercise. I'm only going to look at the impact of 1 day returns. If you were doing this in real life, you would want to consider probably longer run impacts as well. But this is just a simplified model. So you can see, wow, this really doesn't look good. Okay, here we go. So the first thing to do is estimate the difference in difference model, which is really just here you're estimating returns against a dummy for being in the treated category, which in this case is just Equifax, an indicator for post, which in this case is just the event date, and then an interaction between the two, treated times post. And when we get this, as you see, the actual return is a 13.6% drop. So what we're doing is we're netting out basically the other like competitor returns and the market returns that happened on the same day. And so this way, if Equifax fell, but there was also a huge market movement at the same time, we wouldn't give full credit to that drop in returns from the Equifax breach, right? But in this case, there was really nothing else that was going on. And as we see, the difference in difference model gives us an estimated drop due to the breach that is almost identical to that day's return, right? And so this should give you confidence that the model is really working as intended. But with difference in differences, you want to do some validation work. And so one of the validations for difference in difference is that there's no difference in trend prior to the event. And so I take the data and I look only prior to the event date. So it's all before the breach happened. And I estimate the same model of returns, but this time on treated, a trend variable, and then the interaction of treated times trend. And you can see that there's effectively a zero difference in trend, and the p-value is 0.85, so it's extremely small, not even close to statistically significant. And so this is really good for a difference in difference in that in the pre-period, we have no evidence that there's any difference in trend, and so no reason to believe that it would change afterwards. And another assumption is that the model is not biased. So if we run the exact same model that we did for real, but we look at periods prior to the event date, the estimates we get from the difference in difference should be close to zero. And so what I do is I take data that is only prior to the event date. I run the difference in difference. Here's just one example, and you see we get an estimate that is fairly close to zero and with a p-value that is nowhere close to statistically significant. And this is for the day before the breach. And then what I do is that's just really one example, but I then do this for roughly 100, 83 different dates, and I get a distribution of what the difference in difference estimates would look like from all these days before the actual breach happened. And what we see is that The median of those values is extremely close to zero, suggesting that it's unbiased. The p-values also. One thing to be aware of is that these estimates are they're not fully independent. And so we get a share of p-values less than 0.05 at just 1.2% of them. But we can get an empirical distribution of the estimates. And what we see is the 95% confidence interval of the estimates. Again, this is all placebo before the event happened, are between negative 1.5% and positive 1.5%. So that's basically what we would expect daily volatility to be from the model. And as you can see, this is the histogram here between the two vertical black lines is 95% of the pre-breach difference estimates, and the red line is what we get from the event. And you can be pretty confident that those results are due to the breach and not just, say, day-to-day volatility. Look how far away it is from the histogram. So this is just stock prices here. It's possible that Equifax could ask you to do something like this. You would probably use a longer period than 1 day. 1 day is very common, though, in economic litigation, economic consulting. But this technique is very common for solving problems such as, what is the impact of, a website outage or any sort of bad experience for the user.